am on page 13 of our unit packets. We're going to be going over adding and subtracting rational expressions. Now, this is similar to adding and subtracting fractions, so I'm going to do an example. 2 over 3 plus 1 over 6. Now, because I have addition here, same thing with subtraction, I can't do anything straight across like multiplication. I have to get my denominators to be the same. So I know that I can get my denominators to be the same if I multiply this fraction here by 2, and whatever I do to the bottom, I have to do to the top. And this would give me 4 over 6 plus 1 over 6. Now I can add them across just the numerators, and I get 5 over 6 as my answer. So whenever we have adding and subtracting with rational expressions, we need the denominators to be the same. So let's look at this first example. It says factor the denominator of both expressions and find the least common denominator. So I'm going to factor this. This one, there's no greatest common factors to take out. So the only one I really need to factor here is this one. Now, the first question I ask myself, is there a greatest common factor? There is no greatest common factor. The second question I ask myself, is there a number in front of the x squared? Because we have a number in front of the x squared, we have to use the box method. Okay, I take that back. You can use other methods outside of this class. However, in this class, we've just focused on the box method. So I'm going to go and start my box. I'm going to put my first term in the upper left-hand corner, 2x squared. My last term in the lower right-hand corner. When I do my x, I can't forget this. I have to take my last term and multiply my last term by the 2. The first term times the last term. So 2 times a negative 1 gives us a negative 2. And then my middle number here is an invisible 1. So I put my 1 there. Two numbers that multiply to negative 2 and add to 1. I know that a positive 2 and a negative 1. 2 times negative 1 gives me a negative 2. 2 plus a negative 1 is 1. When I add my pair to the box, I have to put an x. Don't forget to add an x. Now, when I add my pair to the box, it does not matter which box you choose. So I'm going to take the greatest common factor of this column. The only thing I have in common is an x. I'm going to take the greatest common factor of this column. If there's not a greatest common factor, I know it's just going to be 1. The greatest common factor of this row will be 2x. Greatest common factor of this row is going to be a 1 or a negative 1. So let's check here. 2x times x, 2x squared. Good to go with that. Negative 1 times x, negative 1x. Negative 1 times 1 gives me negative 1. So I know this must be a positive 1 to give me a negative here. 2x times a positive 1 gives me a positive 2x. So here are my factors that I'm going to use to replace this denominator. So this is going to be 3 over 2x minus 1 times x plus 1 minus 2 times 2x minus 1. Now, if I'm subtracting here and I need my denominators to be the same, just like I did up here, I wanted my denominators to be 6. I figured out what the 3 was missing. I know 3 times 2 would give me 6. Let's look here. What is this, the bottom of this fraction, missing? And I know that this has the 2x plus 1, but it's missing the x plus 1. So if I want the denominators to be the same, I just add an x plus 1. And whatever I do to the bottom, I do to the top. Now that my denominators are the same, I'm going to write it all over one fraction. So I'm going to have 3 minus 2 times x plus 1 all over 2x minus 1 times x plus 1. The next step is simplify the numerators. Once you have your least common denominator, you're done with the denominator. All I want you to focus on is the numerator. So looking at the numerator, if I want to simplify this, I can distribute this 2. When I distribute the 2, make sure to distribute a negative 2 because the 2 has the sign to the left of it. So this would be 3 minus 2x minus 2 because negative 2 times 1 is minus 2. And then what? Combine like terms. My like terms here are 3 minus 2 to give me 1. So I have negative, let's do that here, this step. So 3 times a negative 2, that reduces to negative 2x plus 1, or you can write as 1 minus 2x, it doesn't matter. 2x minus 1, x plus 1. Here's the really tricky thing about this problem that's important for everyone to know. So it's this idea of taking out a negative 1. Take out a negative 1. So the reason why, I noticed that negative 2x plus 1, that's so close to crossing these out. I really want to cross these out. So I want to think, how could I get this negative 2x plus 1 to look like this, positive 2x minus 1? I know if I take out a negative to my numerator, then this will become positive and this will become negative. So let's see how that works. Taking out a negative means the 2x becomes a positive because I'm taking out the negative from it. And if I take out a negative here, that means I'm left with a negative 1. The reason why I did that is because now I have 2x minus 1 over 2x minus 1, and these can cross out. So this isn't, even though I cross this out, that doesn't mean I have negative 0 on my numerator. I have an invisible 1 here. So this is negative 1 over x plus 1. So that is my final answer, negative 1 over x plus 1. And I can box it. If you guys didn't recognize to take out a negative here, the answer wouldn't be fully correct. You have to see if you can take out a negative to see if things can cross out. And if numbers are so close to being crossed out, I always want you to ask yourself, can I take out a negative 1 to cross things out? Okay? So the key thing with adding and subtracting that's different about multiplying and dividing is our denominators have to be the same.